Good morning, everybody. Happy Mag Facts Monday. It's Kobe Pope, owner and creator of Wolf Self Care Products. Today, we're going to go through the 5 general functions and then go in depth about the 14 functions of magnesium. Thanks for tuning in. It's going to take a little bit, but bear with me. Thank you. So, the 5 general functions are magnesium catalyzes most chemical reactions in the body. Number 2, it produces and transports energy. Number 3, it synthesizes protein. Number 4, it transmits nerve signals. And number 5, relaxes muscles. Now on to the in-depth functions of magnesium. Number 1 being energy production. Magnesium is most important for the creation of trillions of cells. Energy production. Magnesium is a cofactor in the production of ATP via ATP synthase. ATP is manufactured within the mitochondria and is bound to magnesium ion. It must be bound to the magnesium ions to be biologically active. There are 1,000, 2,000 mitochondria in each human cell, and ATP is made in each one through a series of 8 steps called the Krebs cycle. Which is remarkable about magnesium is that 6 of the 8 steps of the Krebs cycle require magnesium. Wow. Alright. Number 2, membrane stabilization. Magnesium is an important membrane stabilization agent. Stabilization increases excitation of nerves and excess contraction of muscle cell membranes. Number 3, protein production. Magnesium is required for the structural integrity of numerous body proteins. To date, 3,751 magnesium receptor sites have been found on human proteins. Number 4, we got RNA and DNA. Magnesium is required for the structural integrity of nucleic acids. Consequently, magnesium is required for RNA and DNA production. Number 5, GTP-ACE. Magnesium is a cofactor for the enzyme guanosine triphosphate. GTP-ACE has many functions, A being signal transduction or switching on specific receptor proteins located on cell membranes and transmitting that signal to trigger taste, smell, perception of light. And then section B for this is protein biosynthesis. Section C, control and differentiation of cell division. Section D, translocation of proteins through cell membranes. Section E, transport of vesicles within the cell and assembly of vesicle coats. Now we're on to number 6, phosphorylase C. Magnesium is cofactor for phosphorylase C, which is a class of enzymes that split phospholysis at the phosphate group, creating signal transduction pathways. Most important one allows calcium to enter cells. Number 7, we've got adenylate silase. Magnesium is a cofactor for the enzyme adenylate silase. This enzyme converts ATP into cyclic adenosine monophosphate or CAMP and phosphate. CAMP is used for intracellular signal transduction of the effects of hormones such as glucagon and adrenaline into cells because the hormones can't pass through the cell membranes. It is involved in the activation of protein kinases and regulates the effects of adrenaline and glucagon. It also binds and regulates the function of ion channels or gateways into the cell. Number 8, we've got guanylate silase. Magnesium is cofactor for the enzyme guanylate silase. This enzyme synthesizes cyclic guanosine monophosphate, also known as cGMP from guanosine triphosphate, GTP, keeping cGMP gated. Okay. Number 9, up to 800 enzyme processes. Magnesium is required cofactor for the activity of hundreds of enzyme processes. Number 10, it regulates ion channels. Magnesium is a direct regulator of ion channels, most notably other key electrolytes, potassium, calcium, and sodium. Magnesium is involved in potassium transport. Magnesium and potassium depletion cause similar damaging effects on the heart. It is impossible to overcome potassium deficiency without replacing magnesium. That's why hospitals have such a hard time finding the right electrolyte balance of sodium, potassium, calcium, and chloride because they ignore magnesium and do not routinely measure it in their electrolyte panels. When they do test for it, they use an inadequate serum test or inadequate serum magnesium test. Number 11, intracellular signaling. Magnesium is an important intracellular signaling molecule itself. The role of cell signaling cannot be underestimated. Without intracellular communication, the cells of the body will not be able to function at all. Number 12, oxidative phosphorylation. Magnesium is a modulator of oxidative phosphorylation, during which electrons are transferred from electron donors to electron acceptors, such as oxygen and redox reactions, using magnesium as a cofactor. These redox reactions, called electron transfer trains, form a series of protein complexes within the cell's mitochondria that release energy as ATP. Number 13, we have nerve conduction. Magnesium is intimately involved in efficient nerve conduction above. Okay, you have read about the detrimental effects of excess calcium. Although calcium is vital for proper nervous system function, too much calcium is dangerous. Excess calcium is pro-inflammatory and can excite nerves to the point of cell death. And last, we have number 14, muscle function. Magnesium is intimately involved in efficient muscle function. Mechanisms are varied and include oxygen uptake, electrolyte balance, and energy production. Magnesium makes muscles work properly, allowing calcium to cause muscle contraction and then pushing calcium out the muscle to allow muscle relaxation phase. In the same way that nerve cells can be excited to death, muscle cells stimulated by too much calcium can go into uncontrollable spasm, resulting in tissue damage such as occurs in a heart attack. So that's all I got for you guys. Thanks for watching. Happy MagFacts Monday. You know to shop for the best supplements, www.wlfcalfcara.com. And if you need an automobile, you know to holler at me. Hit me up. Shop. I'll get you in whatever you need. Thanks for watching.